So, what I'm going to start today is a very important type of question. It comes almost every year. Like in some way or the other, they modify it, but it comes every year. These type of problems. Okay. I hope I'm like audible clearly, right? Please be interactive. You can ask me anything, anytime, and let me know if everything is fine. Okay, so I'll start with this question. This is a question of gate 2021, question number 29 of set 2. Okay, so it's a frame EFG shown in the figure. All the members are prismatic and have equal flexural rigidity. The members Fg carries a uniformly distributed load W per length. The axial deformations of all the members are neglected. Okay, so the consider the F joint F being rigid, the support reaction at G is. So we need to find the support reaction at G. So there are four options of course, and if you want to know more about these kind of problems, you can refer to lecture series on structural analysis 1 by Professor Amit Shaw. Okay, he's from IIT Kharagpur. So before starting the question, I just wanted to ask you a simple question, whether this frame is statically determinate or indeterminate. Anyone can answer in the chat box maybe. Is this frame EFG is statically determinate or indeterminate? Can we solve it directly using equilibrium equations, or we need compatibility equations also? Anyone can answer in the chat box. You may be right or wrong. I'll explain, of course. Any idea? Statically determinate or indeterminate?
Ma'am, it is depending on number of reactions.
Yeah. And how many reactions would be? Any idea?
If there is three or more reactions, then it is
हाँ ठीक है चलो.
indeterminate.
Okay, ठीक है. Any other person would like to write in the chat box determinate or indeterminate? Okay, then I'll tell you. He's right. It depends upon the reactions. But even by looking at the structure, you can say, of course, whether it is determinate or indeterminate. So what are the different type of reactions that will occur in this structure? Okay, let me draw. So when the reaction will occur? The reaction will occur when there is a restraint to motion. Okay, let us consider first joint E. I'm considering joint E. Can this joint move upwards? Can this joint move upwards? You can you can write yes or no maybe to be more interactive.
No, ma'am.
No, right? This joint cannot move upwards because it is fixed. Since there is a restraint to motion in upward direction, therefore there will be a reaction in upward direction. Okay, whenever there is a restraint to motion, then reaction will occur. Since it is restrained to motion in the vertical direction, therefore there will be a reaction in vertical direction. Now quickly tell me whether there will be a reaction, whether it is restrained to motion in horizontal direction as well or not.
No, ma'am.
It is restrained, right, in horizontal
Yes.
direction. Can it move horizontally? Can this joint E move horizontally? No, right? Since it is
No, ma'am.
fixed. Since it is restrained to motion in horizontal direction as well, therefore there will be a reaction in horizontal direction. This is a fixed support, therefore it cannot even rotate. Since it cannot rotate, therefore there will be a moment also. There will be a moment also. So there are three reactions: E vertical, E horizontal, and moment in E, let's say. Okay, so there are three reactions at joint at support E. And let's see now support G. At support G, let's see what happens. Can this move upwards? No, because this is simply supported. It is having a roller support. It cannot move in upward directions. Since it cannot move in upward direction, therefore there will be a vertical reaction. Can it move in horizontal direction? It's a roller support. Can it move in horizontal direction? Yes, it can move because it has rollers, right?
No.
Yeah, it has rollers, so it can move in in horizontal direction. Therefore, there will be no reaction in horizontal direction. Whenever the motion is possible, there will be no reaction in that particular direction. It is a roller support, it can rotate. Therefore there will be no moment. So how many reactions in total? One, two, three, four. Four reactions in total. How many number of equilibrium equations we have? We have three equilibrium equations. So,
Three number.
so therefore degree of static indeterminacy is 1. Hence, it is a statically indeterminate structure having a degree of static indeterminacy as 1. I hope you got this. I'll be covering more questions on static and kinematic indeterminacy. It is very important topic. So just to give you an idea before starting the problem, this problem is statically indeterminate by how many degrees? By degree 1. How did we calculate? You have seen that, right? So it is a statically indeterminate problem. We cannot solve it directly by using equilibrium equations. Now, how to solve this support reaction G? So there are many methods to solve this, to get the support reaction at G, but the easiest and the fastest way is by using the standard deflection formulas. You can use the unit load method also, you can use other methods also, but the easiest and the fastest way is by using standard deflection formulas. Since in gate we have to solve the problem very quickly, so you should at least know this method because you'll be using it in many problems. So we know some standard deflection formulas, right? Suppose whenever there is a beam, it is having a load P at this end, so it will deflect like this. And what will be the value of this delta? Delta is PL cube by 3EI. If you don't know these standard deflection formulas by now, you should note that down in a maybe in a chart or something, and put it on a wall in your room so that you will remember these formulas, because these are very very important formulas. Similarly, if there is a UDL, how will this beam deflect? It will deflect like this. And what will be the value of this deflection at this end? This value of this deflection will be WL4 by ATI. If you don't know, you should remember. Okay, you have to learn these values. And what will be the value of theta here? The value of theta, that is slope at the end, will be I don't remember it right now. Okay, okay, we don't require it for this problem. WL 4 by ATI, right? And other thing which we should remember, right? Suppose there is a moment M. So how will this beam deflect? And what will be the value of delta? The value of delta at this end will be ML square by 2EI. And the value of theta will be ML by EI. These are the formulas which we will be using for this problem and for the other problems as well. So there are other different types of loads as well. Like suppose we have a triangular load as well. So there are formulas for delta and theta for these type of loading also. So you should remember at least some of them, at least basics. You should remember that the slope and deflection value for moment, for point load, and for UDL. It is clear by now, right? So I'm going to use these formulas for solving this problem. It's okay. Shall I proceed? Okay. Okay, I'm moving now. So this is very important and little bit complex for the first time like solvers, but if you'll use it constantly, it will be okay. Yeah. So before starting this problem, I'm writing down some basic deflection formulas. Okay, you should note them down and learn them by heart. Okay, so yeah. So please note down these basic formulas. If there is a load P, the value of delta will be PL cube by 3EI, and the value of theta will be PL square by 2EI. So these formulas we'll be using. Suppose there will be a UDL. In this case, the value of delta and theta. The value of delta is seen WL4 by ATI, and let's say theta is, I think, WL cube by 6CI. Yeah, 6CI. And suppose we have this moment M, the value of delta will be ML square by 2EI, and the value of theta is ml by ei. So these few basic formulas you'll be using regularly. So please learn or note them down in your copies. Yeah. So we'll start a problem now. Uh, Topic: deflection of fixed beam. Yeah, not fixed beam, how you can say, but simply supported beam. Basically, cantilever beam. There are formulas for cantilever beams. Yeah. So I'll start the problem now. Please listen, and please listen to it very, very carefully. Okay. So our question is this problem is given to us. So in this problem, what we will do, we have standard deflection formulas for cantilever beams, right? So we will break this problem, although it's a frame, but we will break this problem in such a way that we could use those standard formulas. Okay. So we have like broken this problem as this first part and the second part. Please see carefully, right? In the first part, what we have done is we have removed this support G. Okay, we have removed this support G. It's only external loading. Plus, in the second part, external loading is not there, but this support is there. So instead of support, I have put down this reaction, which is, let's say, R. In this part, up till this part, do you have any problem? Can we write this entire structure as sum of these two structures? If we will add, if we will write this structure as a sum of these two structure, will it be fine? Is there anything which is left? We can do this, right? Please listen to it very, very carefully, because in structure analysis we do a lot of superposition, principle of superposition. So it's kind of like that. So we have broken down our structure, our main structure, as sum of two structures. Okay. So this is structure 1 and this is structure 2. Now we will calculate the deflection at point G for both these structures, and we will add these two deflections to get the final deflection at G. Okay. So what we did is we broke down our final structure as this structure 1 and structure 2. We will solve structure 1 and find out the deflection at G. We will solve structure 2 and find out the deflection G, and our final deflection will be the deflection from structure 1 plus structure 2. Okay. Now, so what would be the value of deflection at point G now? Let's see that. Please be patient with this because it's little bit complex, although, but it will be worth it because many gate problems are based on this concept. So when we have applied this load W, how will this structure will deflect? So we'll see that. Please see it, do it careful. This will deflect like this, and this will be like this, right? And also, so this is up because of this. Now this column has deflected like this, and FG has deflected like this. Okay, but there is a load W also, and because of this, the beam will deflect like this. So final deflection diagram will be this pink one. It will be the column will deflect like this and the beam will deflect like this. So this is the final deflection diagram. So you can imagine also, if there is a this kind of frame, if we'll put a load W in it, so it will deflect something like this. I hope you agree. If anyone has any doubt, you can ask me. Okay. There's another like our second structure, how will it deflect? So please imagine, if we have a frame and we apply a point load like this, how will this deflect? So the column will deflect something like this, right? Since we have to maintain a 90-degree angle here, so this thing will be there. Okay. Now we have this point load also, so finally it will deflect like this. Anyone has any doubt in it, you can ask me, because it's I know it's complicated, but we are doing this so that we could apply our standard deflection formulas here. Okay. If anyone has any doubt, you can ask me at any time. So now let's call it deflection number 1 due to load W, and let's call this extra deflection as deflection number 2 due to load W. I'm just naming it right now. Let's call this deflection as deflection number 1 due to load R, which is reaction, and this as deflection number 2 due to load R. So I have, there is, okay, that's a good question. So he is asking, at support G, there is a support, so why it's going upward? Okay, so please see, I have just broken down this structure as structure number 1 and structure number 2. I have replaced this support reaction at G. So in structure number 2, there is no load upwards. So I have just made the deflection profile like this. Now let's see, now see what I'm going to do now. Now I'm applying the compatibility equation you have mentioned here. Like you asked that why it is going upwards, since if there is a support at G. So now that is the compatibility equation I'm going to apply. Now, final deflection at G, we know that it should be 0. So what I'll do is deflection due to this load W, I'll equate it with deflection due to load R. It is a reaction, but I have named it as load R. So deflection due to W will balance the deflection due to R. It means that the support G is not moving. This is the compatibility equation I'm going to use. So what is the deflection due to W? Is deflection 1 plus deflection 2. And what is deflection due to R? It is deflection 1 plus deflection 2. So now the thing you mentioned is why it is moving upwards. So it's not moving upwards. We have just broken it into two structures, but finally we'll apply this compatibility equation, which will suggest that this support G should not move upwards. Therefore, the deflection due to W is equal to deflection due to R. So deflection due to W will be in downward direction and deflection due to R is in upward direction. So they'll balance each other and finally there will be no deflection. It is complicated, I know, so I'll explain it again. Okay. It is very important because you have, if you have want to apply this formulas later on, so you should know how to draw the deflection diagrams. For this, you have to use a little imagination. Okay, now I'll explain it again. So we need to calculate the value of this reaction R. This reaction R, I'm just removing the support for now. Suppose there's a reaction R, so we need to find this value of reaction R. So for this, what I have done is I have broken this structure into two parts. This is part 1 and this is part 2. Please note that while breaking the structure in this way, please do not leave any force behind. Okay, I have not left any force. In the first part, I have covered this UDL, and in the second part, I have covered this reaction. There is no force which is left behind, right? So what I'm going to do, I'm calculating the deflection due to this load W, and I'm going to calculate the deflection due to this reaction R, and finally I'm using the compatibility equation, that is the deflection at due to W should be equal to deflection due to R, and by using this compatibility equation I am calculating the value of R. Okay, because we are asked the value of R. Also, since it is an indeterminate structure, so that is why we cannot solve it using the static equilibrium equations alone. We need to use some compatibility equation. So this is the compatibility equation I'm using, that deflection due to W is equal to deflection due to R, because finally the point G is not moving anywhere, so we have used this compatibility equation. I hope it is clear. If it is not, please see this video again maybe, or I'll explain it also again also. Yeah, so now what we need to do is we need to solve this equation. Delta W should be equal to delta R. That is the compatibility equation. So we will solve for delta W and we will solve for delta R, and we will equate them, and from that we will get the value of R, because we are asked the value of support reaction R. ठीक है? Okay then. So how to calculate delta W and delta R? So for this we will use our standard deflection formulas now. Now the problem is easy, because once you understand this concepts, so how to break the problem and how to draw the deflection diagram, then it will be easier, because then you just have to use the standard deflection formulas. Now I have told that this first structure will deflect like this. So you should have some idea so that how it should deflect. It will deflect like this, and finally this, due to this weight also, this shape will be this. So this will be delta 1 W, and this will be delta 2 W. Okay, do you understand
Hello, ma'am.
Yeah.
Ma'am, how delta 2W occur?
Okay, ठीक है, I'll explain it to you. See, this structure, okay, so what this load W is doing, due to this load W, if we'll just see the column part, we'll just see the column part. So, and I'm drawing just a free body diagram to make it more clear to you. I hope you should know free body diagram. So I'll this is W. So what will be the moment here? The moment will be WL, that is the force, multiplied by L by 2. So moment will be WL square by 2. This moment will be here also. For now, let's say it WL square by 2. So what, due to this load, there is a moment, okay, and because of this moment, this the first column is deflecting like this, okay, but now, so it has deflected like this due to this moment. So since we have to maintain this 90-degree angle here, okay, so this beam will deflect like this because of this. Now I have till now I have not considered the deflection due to this UDL. Now I'm considering the deflection due to this UDL also. So this beam will further deflect like this. Finally. Is it clear?
Yes, ma'am.
Okay, I'll explain. I know it's a little bit complex, but like, you have to be patient because structure analysis is a little bit complex also. So what we are doing, that this entire frame is deflecting. So first I'm considering the deflection of this column only. So this column will deflect like this. Since this the joint F is rigid, so it will have to maintain this 90-degree angle. So it's 90-degree here. So this beam will deflect like this. But you can imagine also, if there is a load in this beam, can this beam remain straight? No, right? This beam has to like little bit curve down. So this is like this. So hence there are two deflections. This may be called as deflection number 1, and this may be called as deflection number 2. So you have to use a little bit of imagination. Suppose there is a frame like this and you have put a weight on this. So can it be like this beam FG, can it be like a straight line? No, right? It has to curve a little bit. So we have called this that deflection as delta 2w. Okay, so how will you calculate delta 1w? So this is the main concept behind it. Other than that, the problem is not very difficult. So how will you calculate delta 1w and delta 2w? Okay, so as I have said it earlier, if we draw this free body diagram here, this is w, l, this is w. Okay, this load is w. What will be the moment here? I hope you know how to calculate the moment. The moment will be force into distance. The force is w into l, and what is the distance? This will act at the center, right? So l by 2. So this will also be w l square by 2. This is the moment in this column. Hence, delta 1w will be equal to, so this case is like when a cantilever beam is having a moment at, this is this case. So for this case, what will be the value of this delta and what will be the value of this theta? Value of delta is ml square by 2ei, value of theta is ml by ei. Okay, so let's see. So now this delta 1w will be equal to this theta multiplied by L. Okay, this theta will be this theta due to this moment. So delta 1w will be equal to, theta will be ml by ei. We know from this standard formula that this, if this beam will deflect like this theta will be ml by ei. Okay, so this theta will be ml by ei, and finally delta 1w will be ml by ei into L. Okay, so finally delta 1w will be m was wl square by 2 into L by ei. This is the value of delta 1w here. Any doubts regarding this? Okay, I'll explain it again maybe. Okay, so finally what do we need to calculate? We needed to calculate the value of delta 1w. So from the diagram you can see that delta 1w will be equal to theta times this length. Okay, please listen to it very carefully. It is complex, I know. Delta 1w will be this theta multiplied by this length, right? And what is the value of theta? The value of theta we can calculate from the standard deflection formula. The value of theta for this case is ml by ei. And what is the value of moment? We have calculated moment is wl square by 2 ml divided by ei multiplied by L. So this is the value of delta 1w. If you have any confusion, I know you will have you will have confusion. So please let me know what is the thing you can't understand here. Maybe when I give you the practice problem, then it will be more clear. Please let me know what is the problem. Anyone? Any problem?
No, ma'am.
Okay. Okay. So delta 1w is equal to wl4 by 2ei. It is the value of our delta 1w, wl4 by 2ei. Now, how to calculate the value of delta 2w? So delta 2w is very easy. So it's delta 2w is a case of this cantilever beam with a UDL. So what is the value of deflection due to cantilever beam? It is equal to WL4 by ATI. These formulas you have to remember just. So delta 2W will be WL4 by ATI. So delta 2W is known to us now, WL4 by ATI. So total deflection at due to W is equal to delta 1 W plus delta 2 W. So delta 1 W was WL4 by 2 EI. Okay, maybe I have done one mistake here. Yeah, I know that. You have not pointed out it out, but let's see.
Yeah, 12.
Yeah,
It
it's
will be
2L.
12.
It's 2L. So delta 1 W is equal to theta multiplied by L, you know. So theta, it's this theta is for this beam. So theta will be ML by EI, right? So theta will be, what is the value of M? We have calculated it earlier. M is the moment due to this UDL, which is WL square by 2. But this length is the length of this frame, because we are calculating this theta. So this length is 2L. It's 2L divided by EI. EI is same for both the beam as well as the column. So it will cut down. So it will be WL cube by EI. And delta 1 W will be WL4 by EI. I hope it is clear, right? Now WL4 by EI is delta 1 plus delta 2 is WL4 by 8EI. So finally delta W will be equal to 9 by 8 WL4 by EI. I hope it is clear. So delta W we have calculated. So just you needed to understand the basic of this deflection diagram. So how this deflection diagram will be made, and then you should just remember the deflection formulas. Then this problem is not very difficult. It's easy, but you need to practice a lot, because these type of problems will come every year. And if you will use the unit load method or any other method, so you have to do a lot of calculation in that. You have to integrate it a lot, like you have to find the moment in the this beam and column, and you have to integrate a lot of things. But if you'll just remember this concept, for once it will be difficult, like to how to draw this deflection diagram and all. But once you have the practice, that this will be very easy to solve. You'll just see and you just know how to, you have to apply the deflection formulas and find the answer. So I have calculated the delta W now. So what, and now I have to calculate delta R. So delta R, how will I calculate? I have to calculate, so I'll make this deflection diagram again. So please see once again how this beam is deflecting due to this point load. Just imagine if there's this kind of column, then how will this column will deflect? Just imagine, right? So this column will deflect like this, okay? And just forget this beam for now. This column will deflect like this. We have to maintain a 90-degree angle here, so it will go straight up, right? Then we'll consider this point load, and then we will make how this beam will deflect. So if there's a point load here, and the beam will deflect like this. I hope it is clear for, right? So let us call it as delta 1R, and let us call it as delta 2R. Maybe I'll ask after this that some deflected shape. So you should know, because as a like if you will pursue the structural engineering, then you should know at least how the structure should deflect for a particular load, right? Okay, now so for this load R, this structure will deflect like this. Now we have to calculate delta 1R, and we have to calculate delta 2R. We'll add them up to calculate final delta R. So how will we calculate delta 1R? So let's make a free body diagram. For like in gate, you don't have to make the free body diagram. After a lot of practice, you would know what will be the value of moment. Anyway, you should know, like if it is R here, so what will be the value of this moment? This moment M will be, okay, yeah. What will be the value of this moment?
R.
Very nice, very nice. It will be RL, right? Similarly, the moment here also, this will be RL. That's good. So, what will be the value of delta 1R then? Delta 1R is equal to this theta multiplied by this length of this beam. So delta 1R equal to theta multiplied by this length L. Delta 1R is equal to, what will be the value of theta now? The value of theta is simple. Theta is ml by EI, right? What is the value of moment here? It will be RL into L, sorry, 2L by EI. So the value of theta will be 2RL square by EI. It is clear? The same process I have applied. I've calculated the theta as ml by EI, and I've put the value of m as RL, and I've calculated the value of theta. Now what is delta 1R? Delta 1R will be 2RL cube by EI. This is the value of delta 1R. Right? Now we will calculate delta 2R. Delta 2R is very simple. Delta 2R is very simple, and its value is, what is the value of delta 2R? Delta 2R will be simply, since a point load, in the earlier case it was a UDL applied in downward direction, so we use a delta 2R 2W as WL4 by ATI. Now it is a point load applied in upward direction, so what is the value of deflection when the point load is applied? It is PL cube by 3EI. So delta to R, what is the value of P? It is R. What is the value of L? It is L, 3 times of EI. Right? So finally, delta R is equals to delta 1R plus delta 2R. So delta R will be equal to 2RL cube by EI, L cube by EI plus RL cube by 3EI. So delta R will be equal to 7 by 3 RL cube by EI. Okay, delta R we have calculated and delta W we have calculated. So can you now quickly equate delta R and delta W and tell me the value of this force R now? You have to equate the value of delta R is 7 by 3 RL cube by EI. Delta R is 7 by 3 RL cube by EI, and delta W is 9 by 8 WL4 by EI. 9 by 8 WL4 by EI. Anyone please, can you calculate the value of R from here now? EI and EI will get cancelled, right? And L will be there and R will be 27 by 56 WL. So this is our final answer. What is 27 by 56? I guess it's 0.48 something. So this was the option here. Yeah, this is 0.482 WL. This is the final answer. Please practice this problem again and again because you cannot miss it. Otherwise, there will be a lot of questions which will be based on this. Either you want to solve a lot of integrations or you want to solve it like this. This is up to you. because you must have seen in your classes also, you have to do a lot of integration for solving structural engineering problems, but you have seen I have not used a single integration equation here. Okay, so either you just want to learn this concept or and solve the problem, because at this time it was very difficult, like it was very lengthy also. But if you'll practice a lot, then it will be very very easy method to solve and very quick method also, because then do not need to draw the free body diagram and all. You just see and know how which deflection formulas you have to use, and you'll quickly solve the problem. If you want me to explain it again, or if you want me that if you want to solve it using the integration equations, the unit load method and other methods, then it is also up to you. I've just told you one method to solve, and to me this is the easiest method and the quickest method to solve. So if you want me to explain it again, I can do that. Or if you want me, so we'll solve a practice problem, then it will be more clear. So in the practice problem, this is the same question I've given, except I've given now this length, this EI also have differed. It is 2 EI and it is EI here. Okay, so I'll explain the practice problem, then you'll get to know. The same problem is there, just I have differed the EI. So you should keep in mind the value of this length, this EI and all. Okay. So maybe I'll make it easier because this time it was difficult for you. So I'll make it L here and EI here. So EI is same for both the beams and L is same for both the beams. So do you want me to explain this practice problem or you want to try it yourself? Maybe I think I should explain because it was not very clear to you. Anyone, please? Should I explain it again? This problem, this concept, or it is clear? Just you can write in the chat box maybe.
Ma'am, clear, ma'am.
It is clear to you. So you okay, so you please note down this problem. Anyone else? Everybody, it is clear to you? Maybe I can ask Dheeraj, it is clear?
Ma'am, it is clear.
It is clear. Okay, so this problem you can note down, or what you can do is maybe I'll give you a different problem also. You just practice it at home, right? Instead of this structure, let me give you this structure as a homework. Maybe just practice a lot of problems like this. So maybe it is a load P here now instead of this UDL. Other things, all other things are same. EI and everything is same. Length is also this 2L and L. Maybe I'll keep it L here. L and L, and this is EFG, and this is EI, and this is EI. This can also be solved similarly. It is a bit more difficult than this problem. Okay, so try it at home. Let's see if you could at least draw the free body, the deflection profile. That will be a good start. Please note down this problem and try it at home using the same method. Maybe. Okay, so if this problem is clear, we'll start with other type of other gate question, that is based on engineering mechanics. So mostly engineering mechanics problems are very easy to solve. So I'll quickly explain this question since the first problem was a little bit difficult, because I'm not getting any feedbacks from you proper. So I don't know whether it was clear or not, but I tried my best. Okay, so it's another gate problem. Question number 52 of set 2 gate 2022. So please don't leave engineering mechanics problems and structural dynamics problems, because usually they are very very easy. Okay, it's a 2 marks question, and the previous one was also a 2 marks question. You could see the difference, how easy they are and how quickly you can solve it. Okay, so in this question, a uniform rod KJ is shown is shown in the figure. It rests against a frictionless vertical wall. So this vertical wall is frictionless. Okay, at point K, and rough horizontal surface at point J. So this is a rough surface, and this K vertical wall is frictionless. It is given that the weight of this rod is 10 kilonewton. This distance A is 4 meter, and this distance B is 3 meter. Okay, so you need to find the minimum coefficient of static friction that is required at point J to hold the rod in equilibrium position. So you just need to find the coefficient of static friction. You can, for engineering mechanics problem, you can refer to lecture by Professor K. Ramesh from IIT Madras. Okay, now we'll start the problem. It's a very easy problem, and you will see how quickly we can solve it. We'll draw free body diagram for this problem. So now we have separated this rod KJ, and we'll see what all forces are acting in this rod. So since the rod, the same concept, this rod J is supported in vertical direction, so it cannot move in vertical direction. So there will be a reaction called as J vertical. Okay. This point, at this point K, this cannot move in this direction, right? Hence there will be a reaction called as KH. At in the vertical direction, this can move freely because it's a frictionless wall. Hence there will be no reaction in vertical direction. I have put this load W, which will act at the center of this rod, but at point J there will be some restraint to motion because of, since this rod is this surface at J is rough surface, so because of friction there will be a force at J in horizontal direction, and it will be known as JH. The value of friction force we all know from our, like in 10th or 12th you have studied that this horizontal frictional force will be equal to mu times the vertical force. Mu is the coefficient of static friction. Okay, so any other force that should come in this rod, you think? Any other force that should come in this rod, or it is fine? Okay, so I have drawn all the forces that should come in this rod. That is vertical force in J direction, horizontal force in at point J, horizontal force at point K, and this load W. So all the forces I've drawn. So in the free body diagram, we have to draw all the forces, right? So JH, we know that friction force is equal to, that is important here, because this is the key thing here, that friction force is equal to mu times the vertical force. Mu is the coefficient of friction. So everything is given to us now. We have given the value of W, we have given the value of A, B, but we need to find the value of this mu. That is the minimum coefficient of static friction. So we have to calculate the value of mu here. So this problem is now become very easy to solve. We just have to use the equilibrium equation. First equilibrium equation is the summation of force in vertical direction 0, and the second equilibrium equation we can use to find the value of mu is summation of moment about point K equal to 0. Okay, so what will be the value of summation of force in vertical direction 0? It will be uh, what are the vertical forces here? So it will be JV. JV is a vertical. So suppose consider upward force as positive, let's say. So JV, any other vertical force? There's another vertical force, W also, right? So it is in downward direction. So we'll write minus W. There's no other vertical force except JV and W in this rod, right? So JV minus W equal to 0. Finally, the vertical force JV will be equal to W, and W is given to us as 10 kilonewton. So we have calculated the value of JV now, right? Now the another equilibrium equation we have, you can use any other equilibrium equation that could whatever equation that will give us the answer will be right. Okay, the summation of moment about point K equal to 0. So let us see the summation of moment about point K as 0. So it's 4 meter and 3 meter. Yeah, so it is given to us this distance as 4 meter and this distance as 3 meter, right? Okay, so now we'll take moment about point K. Let's see what all forces are there. So if we'll take moment about point K, let us see let's start with W force, that is nearest. So what is this distance? It is acting at the center, so it is 1.5 meter. So moment will be W multiplied by 1.5 meter. Let's say this clockwise direction as positive. You can take any other sign convention, just be consistent with that throughout the problem. So W into 1.5, or other forces, let's say JH. So JH is also rotating the point in clockwise direction only. So plus JH multiplied by, what is the distance from point K to point J? It is 4 meter. And then we'll this JV force is also there, but JV is rotating this point K in anti-clockwise direction, hence it will be negative. So it will be JV multiplied by what is the distance between a perpendicular distance between JV and K. It is 3 meter. We have put it to 0 now. So this W is 10 kilonewton, so it is 15 plus JH, we don't know right now, so it is, let's say, 4GH now, minus 3 times of JV is 10 equal to 0. So we'll get JH as 15 by 4 kilonewton. I hope it is clear. We have just used a simple summation of moment about point K as 0. Now we know that, maybe I'll use this point, okay, this slide, maybe I'll add some other slide. Yeah. So we know that JH, that is the friction force, is equal to mu times the JV, that is the vertical force. So JH, so mu will be equal to JH by JV, right? So mu will be equal to, what is the value of JH? JH is 3.75, that is 15 by 4, 3.75. And what is the value of JV? JV comes out to be 10 kilonewton. So divided by 10. So value of finally friction, coefficient of friction will be 0.375. So this is the value of coefficient of friction we got. Yeah. So this is our final answer. So see how easy it was, and it was a, and we have to calculate it by rounding it off to 3 decimal place. So it's already 3 decimal place, 0.375. So we got our answer as 0.375. Okay, so this is our final answer. So this was also a 2 mark question, and that structural analysis problem was also a 2 mark question. That seemed to be lengthy for first time solvers, but if you'll use it very frequently, if you'll practice a lot, then it will be easier. This type of engineering mechanics, structural dynamics, they usually give very easy problems, so please don't leave these topics. Okay, if you'll know at least some formulas of these topics, then it will be easier for you to solve, and it will be time saving also. So I hope it is clear to you. Please solve this other practice problem given in this question. So let's see how, and maybe you can use because this type of problem will come every year for sure. For sure, this is I can give you a guarantee this will come for sure, because I've seen it like from many years it is coming, maybe in the form of beam, cantilever beam problem, or maybe in the form of frame, but you need to solve this problem a lot. So you can solve different problems like this, and at least it get to know the deflection profile, how for a given load the beam or a frame will deflect. So this is a very important problem, so that's why I took a lot of time for this. Maybe we'll solve other gate problems also similar to this in the coming classes. So get to know this concept well, okay? And the other problem was from engineering mechanics. It was a very simple problem. Just you need to use equilibrium equations. I think it is like enough for today's class. Or maybe there's also a problem of engineering mechanics here. Maybe you can note down this problem and do it as a practice problem, or otherwise I'll discuss it maybe next week. Okay, this is also a kind of problem which can come in engineering mechanics. So any doubts, please you can ask. We still have 5 minutes, so you can ask if there are any doubts. Maybe for deflection profile, if you have any doubt. Yes. Dharini, your voice is like not very clear. Can you repeat?
Ma'am, kindly show the practice problem for engineering mechanics for noting down.
Okay, this is the problem. So this is also a very common problem for engineering mechanics. This even I think it is a 2004 or 2005 problem from a mechanical engineering, because in mechanical engineering also this subject is there, right? So it is a gate problem only from I think 2004 or 2005 mechanical engineering. Okay, so this can come maybe in civil also in some in next year maybe so. Okay, just please note it down. Any other doubts? Okay, two classes. Actually, we are also like we are PMRF scholars here, and we have to do our research work also. But this one class is also very time consuming for us. So we are preparing gate video solutions also for you. So maybe they'll upload these live lectures also, and the gate videos also in the portal maybe in 1 or 2 weeks, so that you can revise from there also. Okay. And there are also I think other sessions are also going on for civil. So I think this much will be enough for you, like from for geotech and for transportation other some class sessions must be going on. So please attend these all sessions, and you can ask as many as questions as you can to us, so we are there for you. Yeah. So this is a government initiative so that you can you don't need coaching, or you'll need less of coaching. So we are here to help you. Okay, so please ask a lot of questions. You all are like strangers to like among you, and for us also you don't know us, right? So you can ask anything to us regarding this gate. Any other problem? Should I end now?
Thank you, ma'am.
Okay, thank you so much. Thank you for listening.
Thank you, ma'am.
Please practice, okay? Because my teacher like used to tell us, please do not leave structures at least, because it's like mathematics. So you should practice at least two problems a day, whatever the situation is, because it's like if you will just see the concept, you will not be able to do that in gate. Okay, if you don't have any practice regarding that. Okay, then thank you so much. Please practice a lot. All the best. Okay, thank you. Uh, can you please suggest
Thank you,
reference?
ma'am.
Okay. What references for which thing? I think for topic wise references I'm already given to you. Just like what the problem what I've shared. So please others can leave if they can. So topic wise references I'm giving already given. Like for this problem you can refer to this lecture by Professor Amit Shaw. He's explaining it very nicely. So you can attend these nptl session. So whatever the problem is, I'll be giving you the references with the same. Maybe I'll give you the lecture number also, which you can see from the next class. Give you the lecture number also. Okay, so you can go to that lecture and understand the problem clearly, more clearly. So this is a new platform for us also, and we'll also learn with you so how to convey our messages very more clearly. Okay, then thank you. Thank you so much for listening. Okay, bye.